All right, we're going to look at section 7.3, and these problems are equations that have fractions in them. And we, knowing how to do fractions, we could do them by getting common denominator. Like for instance, this would be 1/7 of x. We could rewrite it as 1/7 x plus 1/3 x. And then we could combine these two and go from there by doing 3/21 and 7/21. We don't want to do that. We do want to find the common denominator though, which we just said was 21. What we're going to do is multiply every single fraction by that common denominator, every single part, every single term, because this is not necessarily fraction. The reason we do that, let's come over here. Notice 7 can divide into 21. It can go in 3 times. So if we divide both parts by 7, we can reduce there. Here we could divide by 3, so that would go in 7 times. So now we can go ahead and multiply the fraction. So we have 3 times x plus 7 times x, and then this would be 210. Notice we no longer have a fraction, do we? Is that much easier than, like originally, let's go back to what we had. Which one seems probably easier to solve? This one, we've got no fraction. It's just, now we go ahead and combine. 3x and 7x would give us 10x equals 210. Divide by 10, x equals 21. It's not always, but sometimes it could be possible that that's the same as your common denominator. That's just chance here, so coincidence. So let's do several of these together and show you a nice, easy way to figure these out. 3a over 5 minus a over 2 equals 1 over 20. So this time we're dealing with 3 fractions. You want to look at all 3 denominators and figure out what would your common denominator be. 40 would work. Is there a smaller one? 20 would work. So let's go ahead and use 20. So you multiply every fraction by 20. So 5 would go into 20 4 times. 2 would go into 20 10 times. And 20 and 20 would cancel. So 4 times 3a is 12a minus a times 10 is 10a equals 1. 10a minus, excuse me, 12a minus 10a would be 2a equals 1. This is where so many people want to do it mentally and say that it's 2. It's not 2, and you can figure that out if you show your step. A equals what? 1/2. Okay. So for today, these are going to have just a simple 1-term denominator without the variable down there. All right, so this one we have x over 3 minus x plus 2 over 5 equals 2. If you have a binomial in your numerator denominator, put it in parentheses. It'll help make sure you don't, in this case, especially lose a negative. So we have 3 and 5. What would our denominator be? 15. So we multiply every term by 15. So 3 can go into 15 5 times. 5 can go into 15 3 times. Over here, we're left with 30. I'm going to move this 3 over here. So that way we see that it's, I want to distribute it with that negative. So let's distribute negative. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. 5 times x is 5x. Now I want to combine our like terms, our x's. 5x minus 3x. 2x minus 6 equals 30. So now we've got a 2-step equation. First step, get rid of addition or subtraction. Add 6. 2x equals 36. Divide by 2, x equals 18. Okay. Let's do one more together. Just make sure we'll use that next example. 2n plus n over 3 equals n over 4 plus 5. So this one's a little bit bigger. Got 4 terms, and that's okay. What would our common denominator be? 12. So we multiply each term by 12. So 12 times 2n is 24n. 3 can go into 12 4 times. What is 4 times n? 4n. 4 can go into 12 3 times, which is 3 times n, which is 3n, equals, not equals, plus 60. Doesn't seem right. Now we're good. All right, this side, we combine like terms. What do we have? 28n. Now we want to get our variables on one side, so we want to move our n across. Negative 3n. 25n equals 60. Divide by 25. And like I said yesterday, we can leave it improper. That's fine, but we want to reduce it at least. So we get 12 over 5. Okay. So tomorrow we're going to add in, we're going to put variables on the bottom. But for today, it's just getting rid of our denominator by finding the common denominator using that fractional coefficient. So what I want you to do on page 299, 300, let's say, to 23 odd. 399 to 299 to 300, 923 odd.